Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of line in R3. So as per the problem, state where possible vector parametric and symmetric equations for each of the following lines. So let's start with the first line. The first line passes through the point P with the direction vector 3, -2, 1. So let's start by finding the vector equation of the line. We should write the general equation of the line in vector form. In this general equation, vector r represents the position vector of an unknown point that lies on the line. Vector r0 represents position vector of a known point that lies on the line. T is the parameter, which can be any real number. Vector m is the direction vector of the line. Now the line passes through point P, so we can use point P for the direction vector r0. We are also given the direction vector of the line. Now we can sub in these vectors in the general equation. So this is the equation of the line in vector form. Now we can write the equation in parametric form. For that, we'll have to use an unknown point x, y, z for position vector r. Now we can break up this vector equation into the three parametric equations. For the x equation, we'll use the x components of the three vectors. We should multiply the components of the direction vector by t. So the x equation is now we can write the y equation using the y components of the vectors. And next, we can write the z equation using the z components of the vectors. So these are the parametric equations for this line. Next, we have to write the equation in symmetric form. For that, we have to isolate t from the x, y, and z equations. So let's start with the x equation. We should add 1 to both sides. Now we can divide both sides by 3. So this is the expression for t from the x equation. Now we can do the same for the y equation. So this is the expression for t from the y equation. Now we can analyze the z equation. So we can subtract 1 from both sides. So this is the expression for t from the z equation. For the symmetric equation, we should write these expressions for t equal to each other. For the z part, we should put 1 in the denominator. So this is the equation of the line in symmetric form. So we are done with the first line. Now we can analyze the information for the second line. The line passing through points A and B. So let's start with the equation in vector form. We can start by finding the position vector r0, and we can use any of the two given points. I will use point A. Now we can find the direction vector of the line, and for that we should subtract the position vectors for the two given points. We can also do OA minus OB, but I am doing OB minus OA. We can use point B for position vector OB and point A for position vector OA. Now we can subtract the vectors by subtracting their x, y, and z components. -1 minus -1 is equal to 0. 2 minus 1 is 1. And 1 minus 0 is 1. So this is the direction vector of the line. Now we can write the vector equation. So this is the equation of the second line in vector form. Next, we can write the equation in parametric form. We'll use an unknown point x, y, z for position vector r. Now we can break up this vector equation into the parametric equations. So for the x equation, we'll use the x components of these three vectors and we'll multiply the components of the direction vector 0, 1, 1 by t. So the x equation is t times 0 is 0, so we can ignore the term. So the x equation is x equals -1. Now we can write the y equation using the y components. And next we can write the z equation. We can ignore the 0 term in this z equation. So we can rewrite the parametric equations as next we can write the equation in symmetric form, and for that we'll have to isolate the t from these three equations. The x equation has no t term, so we can just write the x equation as it is. Next, we can isolate t from the y. In the z term, the t is already isolated. Now we can write the equation in symmetric form. So we'll start by writing the y and the z parts of the equation because the x equation has no t term. In the y part, the denominator will be equal to 1 and it will be the same for the z part, and we'll write the x equation as just. We cannot write the x equation in the symmetric form because the x component of the direction vector is 0 and we cannot write 0 in the denominator. So this should be the final answer for the symmetric equation for the second line. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.